Hi guys, this is Mrs. Denton. Today we're going to do lesson 8-2, independent and dependent events. Make sure and grab you some notebook paper, take some notes, write down some vocabulary. Let's get started. Remember, you can pause the video at any time if you need to complete anything. Okay, for your warm-up, it says you randomly choose one marble from a bag containing 5 blue marbles, 2 red marbles, 2 green marbles, and 1 purple marble. Find the favorable outcomes of the event. Go ahead and pause the video if you need to and try solving these 6 problems, and then we'll check your work. Okay, looking at number 1, it says find the favorable outcomes of the event. The event is choosing a blue marble. So if we were looking at our options up here, we have 5 blue marbles. So the number of favorable outcomes of choosing a blue marble would be 5. Number 2, choosing a red marble. The number of favorable outcomes for choosing a red marble would be 2. Number 3, choosing a green marble. The number of favorable outcomes would again be 2 because there are 2 green marbles in the bag. Number 4, choosing a purple. We have 1 purple marble, so the favorable outcomes would be 1. Number 5 says not choosing a blue marble. So we're going to include everything except blue. So we're going to come up here and we've got 2 red, 2 green, and 1 purple that we're going to combine. So not choosing a blue marble would leave us with 5 to choose from. And number 6, not choosing a red marble. So we are wanting everything except red. So go up to the bag numbers. We have 5 blue, 2 green, 1 purple. So that would give us 8 favorable outcomes for that event. Okay, we've got some vocab here that we're going to work with in this lesson. The set of all possible outcomes, the set of all possible outcomes of one or more events, so there's a possibility we could talk about more than one event, is called sample space. So every possibility. The second vocab says a compound event consists of 2 or more events, which is the meaning behind compound. You can pause the video if you need more time to complete those definitions. Example 1, finding the probability of a compound event. So remember what the word compound meant in the previous slide, 2 or more events. Okay, it says you roll a number cube and flip a coin. What is the probability of rolling a number greater than 4 and flipping tails? So keyword there, and. Use a table to find the sample space. Now the sample space, if you'll recall, is all the possible outcomes. So when we're looking over here at the coin and the number cube, the coin obviously has 1 head side, 1 tail side. The number cube has 6 sides with the numbers 1 through 6 listed, just like a die. Okay, now over on this right side, you've got your possibilities for the coin, head or tail, and you have your possibilities for the number cube. So if we were to go ahead and combine, anytime we flipped a head on the coin, we could also get a 1, a 2 on the number cube, a 3, a 4, a 5, or possibly a 6. Now that was just with flipping a head. If we flip a tail on the coin, we have the same possible combinations with the number cube. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes for this event. Now, our formula, which we're going to look at next, stands for the probability, the event that we're talking about will go here. The number of favorable outcomes is on the top, and the number of possible outcomes is listed on the bottom. So if we were wanting to, what's the probability of rolling a number greater than 4 and flipping a tail? Okay, that's our favorable outcome. Now, when we look at this, we can see over here in this sample space, that's what we're going to call this table over here. This is our sample space. We have those two favorable outcomes, a number greater than 4 and a tail. Those are the only options that we have out of those sample spaces. So basically we could write this as, with this example, we want the probability of greater than 4 and tails. So we're going to include that inside the probability. And we're going to come over here. The number of possible outcomes we talked about earlier was 12. And the number of favorable outcomes, we had a 5 on the number cube and a tail on the coin. We have a 6 on the number cube and a tail on the coin. So we have 2 favorable outcomes. Favorable means what they're asking us to find the probability for. Now we have 2 out of 12, which will simplify to 1/6. You can do that in your calculator if you need to. Now, something else about probability is that we also may see it written as a percentage. So if you put in 1/6 into your calculator and you have a button that you can convert that from a fraction to a decimal, or you can convert that to even a mixed number. So whatever your options are, whatever you choose to do, if we converted 1/6 to a decimal and then wrote that as a percent, we would have 16 2/3%. You're going to see a repeating decimal, but if you want to convert that over to a fraction, 2/3, and then write it as a percent. That would be the probability of getting a number greater than 4, rolling a number greater than 4, and flipping a tail. Okay, example 2. Finding the probability of a compound event. So now we're going to talk about something that's occurring more than once here. You flip 3 nickels. What is the probability of flipping 2 heads? So we want 2 heads and 1 tail. Now, we're going to set up a tree diagram to find the sample space. In the previous slide, they used just a basic table to find the sample space. This example is going to use a tree diagram, another option you have to find the sample space. So if we come over here, we have our head and we have our tail listed. This is for our first nickel. Now for our second nickel and for our third nickel. So for our first nickel, we have the option head and tail. Our second nickel is going to have the same options, but we're going to pair it up with, let's say we have a head on the first nickel, then it could pair up with another head, or it could pair up with a tail. Our second option or possibility is a tail on the first nickel. If we flip a tail on the first nickel, we can still get a head on the second nickel, or we could get another tail on the second nickel. Now, these are listing all the possibilities or outcomes. Now we flip the third nickel. Again, we could get another head. So we could have this one nickel this one time we could get head, head, head. Okay, we could also get head, head, tail. Now, if we started with the head, got the tail, we could also get another head, another tail. Same thing if we flipped a tail on the first coin. We could get a head on the second one, a head on the third one, or even a tail on the third one. If we got a tail on the first one, we could get a tail on the second one, another head, or another tail. So we have all of these occurring, which lead us now to all the possible outcomes. So if I followed this from head, 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 I wrote it there. Head, head, tail goes next. Head, tail, head goes next. Head, tail, tail. And then if we started down here with our first nickel and we got a tail, we could go tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So those are all of our sample space that's listed there in that column. This is called using a tree diagram to find the sample space. We're matching it up. Yes, there are repeats, but the order in which we did them allows us to find all possible outcomes for our sample space. Now, once again, we're going back to the formula for finding the probability of an event. Again, we have the possible outcomes and the favorable outcomes that we're going to compare for this probability. Now, once we have our tree diagram, we're going to find this sample space that we have. So it says we want the probability of flipping 2 heads and 1 tail. So I want the probability of 2 heads and 1 tail. That's the probability I'm trying to find. So if I use this formula, I need to find my total outcomes and my favorable outcomes. So over here, I can count these up. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possible outcomes for flipping these 3 coins. Now, if I want the favorable outcomes, those are the ones where we have 2 heads and 1 tail. I'm going to list only 2 heads and 1 tail. So this head, head, head wouldn't work. I have a head, head, tail. This one would work. I have a head, tail, head. That would work. Head and 2 tails. Nope, we don't want that one. Tail and 2 heads. Yes, another one. 2 tails and a head. 2 tails and a head. 3 tails. So out of these options, the one that fits the criteria in my question, 2 heads and 1 tail, would be 3 out of those 8. So 3 out of those 8 is going to be my probability. Now, once again, I can convert that to a decimal and then write it as a percentage with my calculator, and we get 37.5%. Okay, we've got some more vocab here. Compound events may also be labeled as independent or dependent events as well. Events are independent if the occurrence of one event does not affect the likelihood that the other event will occur. The example previously with the number cube and the coin, those had no impact on each other. So those would be independent events. The key idea at the bottom of this slide just states in words the probability of two or more independent events is the product of the probability of the events. So product in math means multiplication. So if we have a number of events and we want to calculate the probability and they are independent, we are going to multiply those probabilities, whether we have 2 or whether we have 3. We're going to multiply the probabilities to find the compound event probability if they are independent. Okay, here's an example where we have independent events. You spin the spinner and flip the coin. Now the spinner has no impact on your possible coin, whatever you get on flipping the coin. That's why these are independent. What is the probability of spinning a prime number and flipping tails? So we're going to come over here and we're going to focus on the spinner first. So a prime number, remember, it has only factors of 1 in itself. So our prime numbers, if we wanted to list those out, would be 2, 3, and 5. 1 isn't normally labeled as a prime number. So we have 2, 3, and 5 that fit this first criteria. Now, those are the number of favorable outcomes. How many total outcomes do we have? Total outcomes we have is 5. So the probability of spinning a prime number would be 3/5. Now, if we go back and we find our probability for flipping tails, again, we have a total options of 2 total outcomes, and the probability of flipping a tail is only 1. So our probability for that would be 1 out of 2. Now we're going to use the formula for the probability of independent events, which tells us we're going to multiply, and we're going to replace now the probability of spinning a prime number was 3 out of 5. The probability of flipping a tail was 1 out of 2. So we're going to put those into our calculator, and we're going to take 3/5 times 1/2, and we're going to get 3/10, and we can convert that to a percentage also, which is 30%. So 3 out of 10 or 30% would be our probability of spinning a prime number and flipping tails. Okay, now that was independent. Let's talk about dependent. Events are dependent events if the occurrence of one event does affect the likelihood that the other event will occur. If I wanted the probability of flipping a tail and flipping a second tail, did that first event impact the second one? No. If I wanted the probability of rolling a even number with a number cube, that depends on how we're asking about the second event. So our key idea for the probability of dependent events relies on what we're being asked to do after the first event. So the probability of two dependent events, A and B, is the probability of A times the probability of B after A occurs. So we're still multiplying, but we need to make sure that we're following after the second event occurs. So that value could actually change. Example 4. Now we've got an example where we are looking at dependent events. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So, now, these two events can impact each other. So the second event is going to change based on the probability of the first event. Oops, I keep bumping into the wrong thing. Sorry about that. So we have 100 people. That's going to be important. That's going to be our total. 5 of your relatives and 6 other friends. Now, the probability that we're asking to find is one of your relatives is chosen first, then one of your friends is chosen second. Use the formula for the probability of dependent events. So now we're going to take this information and we're going to apply it to the formula. So if I want the probability of choosing a relative, first of all, we want to talk about our total number of people that we have with us. We have 5 relatives and 6 friends. So we have a total of 11 that we're going to use. So the probability of a relative is going to go as 5 out of 11. Now we're going to multiply the probability of a friend after the relative is chosen. So if we take this relative out of our total will drop down to 10 people now that we have remaining to choose from. And how many of those 10 people left are friends? Did we pick a friend in the first one? No. So that number stays the same. It will be 6. And now we're going to multiply these two probabilities. So 5 times 6 is 30. And 11 times 10 is going to be 110. And now we're going to take that and we're going to turn that into a percentage in our calculator. And we will get 27 and give me just a second here. Actually, we could do that as 27 decimal 28%. So 30 out of 110 total outcomes, or 27.28% if I wanted to round that. I could convert that also to a mixed number if I needed to. So finding the probability of a dependent event, notice how the second one changed based on taking out one of those people for the first contestant. Okay, we've got one more vocab that we're going to look at today, and that is the fundamental counting principle. Sounds very formal, but it states if one event can occur in m ways and another event can occur in n ways, then the total number of ways that both events can occur is m times n. So we're multiplying the number of ways that we have an event that can occur. Example 5. Use the fundamental counting principle to find the total number of possible outcomes. So going back to this definition, we need to know the number of ways each event can occur, and then we can find the total. So if I am looking at my pizza options here, I have size and I have topping. How many options do I have for size? I can get a small, medium, large, jumbo. So we have 4 there. The topping, I can get cheese, pepperoni, sausage, veggie, supreme. So my number of toppings is 5. So if I take 4 times 5, the total number of possible outcomes would be 20. So that's applying the fundamental counting principle to find the total number of possible outcomes. You take the number of choices and you multiply them.